Well, hello everyone. Today we will talk about the electric field due to dipole at its equatorial position. So what is the equatorial position? Equatorial position means we will try to find out the electric field due to a short dipole. Remember, a short dipole at an equatorial position. Equatorial position means a line which is perpendicular to the dipole. So here you can see this is a point, equatorial point P, where we want to find out the electric field. This is the line which is perpendicular to the dipole, and here AB is a short dipole. A is minus Q charge here and B is plus Q charge. So here we have two charges, plus Q and minus Q. Okay, so you want to find out the electric field at point P. As I have told you earlier that you should always mention the figure, so you can mention the figure. That figure shows an electric dipole consisting of two charges, plus Q and minus Q, etc., etc. Just try to write whatever is visible to you. Okay. Now let us pay attention to the diagram. AB here is a short electric dipole. Here is your A, here is your B, is a short dipole. P is the equatorial point or the position where we want to find out the electric field. Now see, due to plus Q charge, electric field here is in this direction. Okay, and due to minus Q, which is repulsive. Remember, electric field due to plus Q is repulsive, and electric field due to minus Q is in this direction, which is attractive. That means minus Q is attracting P towards itself, and electric field due to Q is repelling point P away. Well, here one of the most important thing here is this angle theta, which we have mentioned here. Let P be the distance. Let P be the distance. P be some point at distance r from the dipole where we actually want to calculate the electric field, and it is making an angle theta here. Which angle it is making? It is making an angle theta with the dipole. Now the rest of the thing you need to understand from the diagram here is that if this is angle theta, then according to the convention this will also be theta, this will also be theta. For that you need to go to 11th standard chapter 5, you revise and you will understand these things very easily. Now electric field due to plus Q charge, we are calling it E plus Q here. Electric field due to minus Q, E minus Q here. They both have components, and the components, the perpendicular components of both of which are perpendicular to each other. Here is one component and then other one is in downward direction. So both these components are equal in magnitude and opposite in direction, therefore they cancel each other. The sin component, sin theta वाले component, वो दोनों component एक दूसरे को cancel कर देते हैं. तो बचते कौन से हैं? E Q cos theta. तो देखिए ये जो थीटा है, ये थीटा की ये वाली जो साइड है जिस पे मैंने दो एरो बनाए हैं, दिस साइड हियर, ये साइड थीटा की एडजेसेंट साइड है. तो E प्लस Q का भी वो cos थीटा कंपोनेंट है जो मैंने प्लस साइन से दिखाया है, और E माइनस Q का भी cos थीटा वाला कंपोनेंट उसी डायरेक्शन में है यहाँ पे, इसलिए मैंने E प्लस Q माइनस Q दोनों चीज़ें डायग्राम में एक ही साथ मेंशन की है. ठीक है, सो E ड्यू टू प्लस Q, E ड्यू टू माइनस Q, दोनों के जो कंपोनेंट है हॉरिजॉन्टल कंपोनेंट विच इज पैरेलल but in opposite direction of the dipole moment, they are here with, I have tried to show them with the two arrows. So ये दोनों component यहाँ पे add हो जाते हैं. Okay, so as I have told you that the perpendicular component here, they are equal in magnitude, opposite in direction, they cancel out, but the component which doesn't get cancelled here are horizontal component. So what is the electric field due to plus Q and minus Q charge? Well, you can write it down, kq by r square. R is this distance, So from the Pythagoras you can write it down. This is r square a square, so r square a square square root of a square r square will be the distance. So what are the horizontal component? It's e due to plus q cos theta, e due to minus q cos theta. Here with e due to plus q, e due to minus q, you can also write down the term cos theta. Okay, so here it is cos theta. So e due to plus q, e due to minus q is the same thing. It's kq by a square r square whole square. Square root का square हो जाएगा वो. Ultimately that equation turns out to be like this. That is your ultimate equation, the equation of the electric field of both the component. So E equatorial therefore becomes E due to plus q cos theta, E due to minus q cos theta. We will have to add them up. So when you add, E due to plus q cos theta, E due to minus q cos theta into unit vector p, and you must pay attention here that I have put a negative sign. Why? Because we have seen that the E equatorial, this electric field at equatorial position, is towards which side? This is, it is towards left, which is in opposite direction of the dipole moment, which is in which direction? Dipole moment here, the dipole moment here is in this direction, so it is in opposite direction to the dipole moment. Dipole moment is towards right, equatorial is towards left, so that's why this negative sign. Just add both of this term, E q cos, to E due to plus q, E due to minus q, they both are same, so it becomes twice. Just substitute the value of E plus q here. So if you substitute the values from the above equation, it is 2kq a square r square. Remember this here square root term, if you square it, so it becomes a square r square. 1 by 2 into 2, so it simply becomes a square r square. And this thing here is because of the cos theta. Cos theta is adjacent side a and hypotenuse was a square r square. So it's bit of a mathematics there. Here the power is 1, here the power is 1 by 2. So 1 plus 1 by 2, the answer here in the denominator becomes 3 by 2. And don't forget to write this p at the end. So ultimately it's minus kp divided by a square plus r square whole raised to 3 by 2. And remember, we are solving here for a short dipole, and we know that for short dipole, when r is very much greater than a, r square in the denominator will also becomes here. This r square will become definitely much greater than a square. So we forget a square here. So r square raised to 3 by 2, that is 2 into 3 by 2 will give you r cube. And that's why here we have r cube. So here, we have here r cube. So that is your final expression of the electric field at equatorial position, which is minus kp by r cube into unit vector p. As I have mentioned earlier, the negative sign indicates that the electric field at equatorial position is in opposite direction of the dipole moment. If you have seen earlier that E axial was twice kp by r cube, twice, it was positive, that means opposite of E equatorial, and it was 2 times, which you can see here. That is clearly E axial is 2 times E equatorial, but with the opposite sign. That's it. So here I have derived the equation of the electric field due to dipole at equatorial position. In the next class we will see that what happens when we place the dipole in uniform electric field. Until then, you read and revise. Thank you.